Hey guys, welcome to the channel once again. So today we are going to discuss this particular problem from permutations and combinations. So what is special about this problem and what is something special that we are going to do in this particular video? So this problem is really difficult. Alright, and we are going to take a very unconventional approach to solve this particular problem. So this is a permutations and combination problem, but we will convert this problem into a pure geometry problem. All right. And this is going to be beautiful. This video is going to be beautiful. You will get to learn a lot of things from this video. So permutations and combinations is completely different branch of mathematics, and geometry is altogether on the other end of the spectrum, a completely different branch of mathematics. So we are going to map this problem, this permutations and combinations problem, to a geometry problem and then solve that geometry problem to get the answer to this particular problem. Let us see how we are going to do that. I promise you, you will get to learn a lot of things from this video. So stay tuned and watch the video till the end. So there are 68 MPs. So MP is a member of parliament. So let's say it is given that there are 68 MPs. All right. Every pair of them support each other or oppose each other. So from these 68 people, all right, there are 68 people. Consider any two of them. So let's say this person and this MP. So these two either support or oppose each other. So you can select any two people in 68 C2 ways, and each pair will be either supporting each other or opposing each other. It is also given that every MP has exactly 42 supporters. If you consider one MP, this MP will have 42 supporters, exactly 42 supporters. So all the remaining people will be in opposition to him. All right. Now, the state has many committees of MPs for developmental work. In fact, every 3 members form a committee. So there will be 68 C3 committees formed. So every 3 members form a committee. Let us say you have only 6 MPs. So these 3 people form one committee, or you can say A, C and D also form one committee. So it is not mandatory that A is part of only one committee. A can lie in multiple committees. So all the 68 C3 combinations will be the number of committees that you have. Now the question is, what will be the number of committees in the state such that all 3 members are either pairwise supporters? So all the 3 members, let us say there is a committee A, B, C. So A, B should be supporters of each other, and B and C should be supporters of each other, and A and C should be supporters of each other. So we have to find the number of ways of that happening, or AB oppose each other, BC oppose each other, and AC oppose each other. So all the 3 members should either support or oppose each other pairwise. So we have to find the number of ways of that happening. Now, when I first encountered this question, I was very clueless. I have read the question and I understood what I have to find out, but I did not know how to proceed about it. And I guess it is the same with most of you guys. All right. So I'm going to explain you the solution for this. And before that, I would strongly recommend you guys to pause this video at this point and think about the question for some time. So let us move ahead. Let us say you have a 68-sided polygon. Okay. Let us say you have a big 68-sided polygon. Something like this. So this polygon has got 68 sides. So since we cannot draw all those vertices, we will draw just some of them and leave it at this point, and let us say there are some more sides here. All right. Now let us assume So since the polygon has 68 sides, there will be 68 vertices of this polygon, correct? Alright. So let us assume each vertex is an MP. So each vertex is an MP. Alright. Now, fine. So every pair of them either support each other or oppose each other. So if you consider this MP either supports this MP or oppose this MP. He either support this MP or oppose this MP. Alright. So if this MP supports the other MP, let us say we plot a green line between those two. And if this MP opposes the other MP, we will put a red line. Okay. Something like this. So this particular MP supports this MP, opposes this MP, opposes this MP, supports this MP, opposes this MP. So what we have to do is from each MP, we have to draw green and red lines connecting all the other MPs sitting on the polygon. That is simply nothing but drawing all the diagonals of the polygon. So if you go to this particular MP, so this particular MP, from here also you will be drawing so many lines like this. Alright. So you will be drawing all possible diagonals. So the relation between two MPs is just the diagonal that is getting formed, and that diagonal can be also the diagonals. We are not only dealing with the diagonals, we are dealing with the sides also. So this side says the relation between these two MPs. So all the connections that we have are the sides of the regular polygon, not regular polygon, polygon, and the diagonals of the polygon. Alright. Now let us move further. In fact, every 3 MPs form a committee. So you have to choose any 3 MPs. So when you have to choose any 3 MPs, if you choose this MP, so it is a triangle that is forming. If you choose these 3 MPs, so one more triangle will be formed. If you choose these 3 MPs, alright, one more triangle will be formed. Like this, there will be one diagonal and this and this. So if you choose these 3 MPs, there will be another triangle formed. So the committee is the number of triangles formed inside this regular polygon. So the relations, so the number of relations 68C2. So you have to choose any 2 MPs. So these many relations will be there. All right. So these are just the number of sides of the polygon plus the total number of diagonals of the polygon. When you sum those two things up, you will get 68C2. All right. And the committee is simply 68C3. This is the number of triangles formed by using the vertices of the polygon. All right. So this is number of committees. So see how beautifully we have converted a permutations and combinations problem into a geometry problem. Now I still have not explained you what the question asks you to find out. So let us explore that. So there is one more crucial information given in the question. So there is 42 supporters. All right. Okay, fine. Now if you consider this MP, so we will be drawing a line that connects all the other MPs to this MP. So what will be the total number of lines we draw for each MP? For each MP, total lines means total relations is 67. So we will be drawing lines to all the other 67 MPs. All right. Now out of these 67, 42 are supporting lines. So 42 are green lines. So from this MP, we draw 67 lines. So 42 of them are green. Similarly, from this MP, we draw 67 lines and 42 of them are green. And that is same for all the other MPs. Alright, so if 42 of them are green, then 25 of them will be red lines. Correct? Now what do we have to find out? What will be the total number of committees such that all three members are pairwise supporters? So we have to have three people who are pairwise supporters. So the triangle, if this is one MP, this is another MP, this is another MP, we will get a green triangle like this. And if those are pairwise opposing each other, so the triangle will look something like this. So we have to find out the number of triangles with all green sides plus the number of triangles with all red sides. That will give you the answer to this question. I hope the problem statement is clear. Okay, let us proceed. So we have to find out number of triangles which has all the green edges or which has all the red edges. But before doing that, let us see what all triangles are possible. This is one triangle that is possible, and this is another triangle that is possible, and this is another triangle that is possible, and this is the fourth triangle that is possible. So these are the four triangles that are possible. So the problem is to find out the number of triangles which are like this one and this one. So then what we can do is, so let us say there are X triangles like this and Y triangles like this. So, and let's say total number of triangles are T. If you do T minus X plus Y, you will get the sum of number of green triangles and number of red triangles. And this is exactly what we are going to do. So to do that, we have to find out X plus Y. Now, how do we do that? So this is the most tricky part of this question. Again, I would strongly recommend you to pause the video for some time and think about this. Okay, let us go ahead and do that. So let us say we choose any one vertex. So let us say this vertex. At this vertex, we know 42 green lines are drawn. Okay, so there are total 67 lines drawn to all the other 67 MPs. So out of those, 42 are green and 25 are red. So if you choose one green line and one red line, so let us say you have chosen this green line and this red line. So the triangle is already formed. So this is the triangle. So if you choose one green line and one red line, it doesn't matter whether the color of this particular edge is red or green. If it is red, the triangle will look something like this. If it is green, the triangle will look something like this. So it doesn't matter what is the color of this edge. What we have to do is we have to go to this particular vertex and then we have to choose one red edge and one green edge. So how many ways can we do that? So that can be done in 42C1. Since we have 42 green edges multiplied by one red edge you have to choose. That can be done in 25C1. Alright. Now you can go and do that at every edge. Alright. So you can go and do that at every edge. So I will multiply this with 68. Alright. Now again, there is a catch here. Let us say you have one MP sitting here, one MP sitting here, and one MP sitting here. Alright. And let us say the mapping is something like this. So you can go to this MP and choose this green line and this red line. Then in that case, this triangle will be formed. Okay. The next case is you can go to this MP and choose this green line, this red line and this green line. Even in that case, the same triangle will be formed. But you cannot go to this MP and choose these two green lines because that's not what we want to do. So this particular triangle is counted twice in this sum, I mean in this calculation. So once when you go and consider one green line from here, one red line from here, once when you go and consider one red line from here and one green line from here. So this quantity has to be divided by 2 because each triangle there is counted twice. All right, moving ahead. So let us see what this gives us. So this gives us all the triangles of this type and all the triangles of this type. So this will give the value of this. So number of triangles of this type and the number of triangles of this type, that sum will be given by this quantity. Let's calculate what this is. 35,700. Now if you subtract this quantity from the total number of triangles, you will get the number of triangles of this type plus the number of triangles of this type, which is what is asked in the question. So now the total number of triangles is simply the number of committees, which is 68C3. 68C3. If you calculate, you will get 50,116. So now the required answer is the triangles of this type plus the triangles of this type will be 50,116, which is your total triangles minus the triangles of these two types. So 35,700. So that will give you 14,416. So this is your answer. I think you have got something to learn from this question. So this is a very beautiful question where you convert a permutation problem into a geometry problem, and then you have to realize that the relation between each pair of MPs is either the side of the regular polygon or the diagonal of the regular polygon. Once you realize that, you have to color the sides and diagonals. So if they are supporters, color it with green. If they are opposing each other, color it with red. And once you have done that, the key thing to do here is choosing one vertex and choosing a green line, one red line and one green line. It doesn't matter what the other side is. You'll always get a triangle of this type or this type. So once you calculate those triangles, you have to realize that each of this triangle is calculated twice. Divide this thing by 2, and then when you subtract this particular quantity from the total number of triangles that are possible, which is just 68C3, you will get the required answer. The triangles of this type plus the triangles of this type. I hope you have got something really good to learn from this video. So whenever you encounter these kind of questions, try to think of it in this way. Alright. So if you like the video, do not forget to like it, share it with your friends and subscribe the channel for more such content. And I do have wonderful videos for you in the end screens. Do not forget to check them out. So if you have any queries, comment section is the way to go. So thank you very much. We'll meet you in the next video.